Welcome to VINDAL'S Academy, and in today's class, I'm going to give you the beginner's guide on how to master the plotting of graph in any exam and in any situation. But please, if this video makes sense to you, don't forget to hit the subscribe button, like this video, and share it so that the YouTube algorithm can be able to share our video to the right audience. All right, if you're looking at this graph booklet, it does not look like the conventional graph booklet you use in schools for WAEC students and some other students. However, the only difference is the fact that they did not demarcate with thick lines to show you where is 1 cm or 2 cm. But in my explanation, I'm going to explain to you what it means to have 1 cm or 2 cm. All right. On a very simple note, I want you to understand that when you have 2 cm, it simply means the same 2 cm from a normal ruler, right? It's the same 2 cm. But even though this ruler is measuring in, 5 cm, but 1, 2, and whatever, 2 cm is just 2 cm. For the one in the ruler and the one on the booklet, they are the same, okay? Now, sometimes they will tell you that 2 cm is equal to, they say that 2 cm is equal to 1 unit. I'm going to explain this first. Sometimes they will say that 2 cm is equal to 5 units. Sometimes they will say that 2 cm is equal to 0.1 unit. I'm going to explain this before I get started because, and all these things I have written, they call it scale, right? Now, what does it mean in a simple tense? They simply means that whenever you see you count every 2 cm, you should call it 1, or you should call it 5, or you should call it 0.5. Now, the question should be, how do you identify 2 cm in a graph? Some people use the word box. I'm not going to use box. I'm going to use line because this is a beginner's class. Look at what I mean. Let me explain it here. Now, 2 cm in this case, have you seen it? This is the graph we are looking at right now. Now, let me tell you I'm zooming it so that you see everything. Now, let's assume I am picking this point. The line may come this way and this way. Don't worry. Now, this is your origin, 0. 2 cm means what? 10 lines. That is what 2 cm means. Now, it means this first line is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is what we mean by 2 cm, right? So, every 10 line will give you 2 cm, all right? Now, you count another 10 line. That's me. What I have just done is that maybe if this is 2 cm, from 0 to this 2 cm, they say that every 2 cm is what? 10 units. That means this is 10. If you count another 10 line, you are going to write what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is another 10. It's going to be 20 because from here to here is still the same 10. But it will be increasing from 0. Then another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 30. But remember, from here to here is still what? 2 cm because 2 cm means what? 10 lines. However, the thing is increasing. This is 10, 20, 30, as the case may be. All right? Okay. Let me explain again. And another way, if you choose to say that 2 cm is equal to 0.1 unit, you know what it means? It means that, let's assume you call this place, okay, let me just give you experience. All right? Now, let's assume you pick this place to be your 0. Then 2 cm is 0.1 unit, right? So what do you do? Can you pause the video and think? So it means 10 lines will give you 0.1. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at this point, you have what? 0.1. That's the meaning. You count another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is going to be what? 0.2. Why? Because you add another 0.1. It becomes 0.2. You now keep going. That's how it is. Now, let me explain one more thing. If you say that 2 cm is 0.1, it simply means that 10 lines is what? 0.1 divided by 10. If you divide 10 on both sides, you have, which is going to be 0.01, right? Now, excuse me, I think I have to. Okay. Good. Let me do it here. Let me do it here, okay? Let me do that math here. Then I'll get back and explain what I want to explain. All right. So now, if you have that 2 cm is 0.1 unit, it simply means, in a very simple term, in a beginner's term, it means that 10 lines is equal to 0.1. Now, if 10 lines is 0.1, then what is one line? Look at what I mean. So, if you say from here all the way to this place is 10 lines, okay? What is now all this one line, what are they representing? And that is what I want to explain. Now, what you should do is 10 lines divided by 10 is equal to 0.1 divided by 10. If you cancel them, you say that one line is equal to 0.01. Now, that simply means that this first line is giving you 0.1. This second line is giving you 0.1. But from here to here is going to be 0.2, 0.3, 0.4. No, sorry, not 0.1, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, and so on and so forth. So if you have 2 cm 0.1, now you happen to have 0.08. How do you locate 0.08? You're going to be adding 0.01, 0.02 until you get to this place, which is 0.08. Now, let me ask you a question. If you're asked to find 0.25, where would this 0.25 be? Of course, if you know that this particular place now is 0.2, 0.25 should be somewhere 1, 2, 3, 4, 5. So because each line is 0.01, 0.02, 0.03, 0.04, 0.05. Now if you say 0.05, let me do it the other place. If you have 0.05 plus 0.2, I'm sure that is correct. 0.2, what would be your answer? So you have 5, 2.0. So it simply means that at this point you're having what? 0.0. 0.25. So this is how graph works. Now you understand what is scale, how to measure scale. Let me do one more thing because of some people, right? Let's assume now on the vertical axis, you are saying that 1 cm is 2 units. Let's take this one. Now it simply means 1, 2, 3, 4, 5. Remember, 5 lines is going to give you 1 cm. So this is going to be, but this 1 cm, they say is what? 2. You now count 1, 2, 3, 4, 5. This place is going to be 4. You won't count that. This is 0. 1, 2, 3, 4, 5. This is going to be 6. Okay? Now, what if somebody asks you to locate? What if from that place they say locate, let's say 4.7? What do you do? See what I'm going to do to locate 4.7. You see, now to locate 4.7, remember, let's go back to that same thing I was doing. Look at what I was doing here. Look at, let me clean here. Okay, sorry. We are asked to locate that place. Now, what I'm going to do is to say that, what I will do is to say that since 1 cm is 2, it means that 5 lines is 2, right? That means one line is going to be 2/5. Now, when you have 2/5, it's going to be what? 0.4. Now, that means each line is giving you 0.4. Now, but you want to locate, 4.7. So remember, let me zoom a little more. So that I will be able to understand this. Now at this point right now, I want to locate 4.7. Now remember that one line is giving me 0.4. One line is giving me 0.4. So the first part here is going to be what? 4.4. This place is going to be what? 4.8. But you are locating 4.7. Now let me zoom a little more for you to understand what I'm saying here. Good. Now this is me zooming. Remember, one more time. Remember, you will not have the ability to zoom your own. But what you do in your own is that you will use your common sense. That common sense that God gave you, you will use it. Now, if this place is 4, sorry, wait, what is it now? Give me a better pen. Good. If this place is 4 and this is 4.4, this is 4.8, do you not think that 4.7 should be very close to that place somewhere here? This is where 4.7 should be, because the middle here should be 4.5. Okay? So this is the kind of assumptions, not assumptions, these are kind of estimation. Is a mathematical thing, right? Both assumption and estimation, they are mathematical terms. These are the kind of things you do when you are asked to plot a graph. Okay? So that is what I am trying to explain to you. Now let's get back to what we are doing. All right. Now the question should be, how then do we plot the graph of the question we have? All right, let's get back. This is what we have. Okay. Now let us plot it. Now you have every vital information you need as a person to understand how my line is going. All right. So I'm going to use, I will prefer this yellow pen. Okay, I'm drawing this one. Okay, now let me check what I have done. Okay, let me finish, let me complete it. 1 unit on the vertical. So let me write that as my scale. I'm going to write my scale. I'm going to say that 2 cm is equal to 1 unit on, let me say on both axes, because of the way this is graph, cannot be extended in your own personal graph. It cannot be extended on both axes. Okay, that is what I'm going to do. So the next thing I will do is also to put this arrow, which is very important. Now what I'm plotting on the vertical is h. So for that reason, I'm going to write h in bracket. I will write the unit cm. Okay, now I will do the same on the horizontal. On the horizontal, I'm going to write, on the horizontal, I'm also going to put this arrow to show that the value continues going, and I'm going to write e square, and I'm also going to write the unit, which is cm square. All right. So my graph is getting set. So the next thing I'm going to do is to, this is where it gets a little tasking for me, not for you, for me, because I'm going to, locate where I'm going to call my values. You will see what I'm saying. You will see my struggle right now. Okay, so what I'm going to do is, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 1.0 for 10 lines. I hope that is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So next one. All right, so I needed to fix these lines because in your graph, in your wire graph, you will see those lines boldly drawn to indicate the to indicate one, two. I mean, not to indicate one. They will draw those bold lines to show you that this is where 10 cm this is where 2 cm started, and this is where it's ending. So I needed to fix those lines before we continue because of the length of the video. Now, the first thing we are going to do is to plot the first 4.5 and 8.7 based on what I have explained. So let's get there. What I will do is, let me zoom it as usual. Let me zoom it as usual. All right. So what I will do now is this is first one, which is 4.5 on the H axis. I'm going to locate 4.5. So to locate 4.5, I am going to now know that if I have, let's say, if I have 2 cm to be equal to 1, remember what I did before. So I am going to say that 10 lines is equal to 1. That means one line is going to be what? 1 divided by 10, which is what? 0.1. So each line is meaning 0.1. So, but I want to locate 4.5 on this particular axis, on the vertical axis, all right? So what I'm going to do is to say, okay, if one line is representing 4.5, is representing 0.1. So what I'm going to do now is to say that if this is 4, this is 4.1, 4.2, 4.3, 4.4. I mean, I am adding 0.1 to the 4 here. I'm adding 0.2 to 4, 0.3 to 4, 0.4 to 4, 0.5 to 4. This is going to be the 0.5. Now, the question is, where does it work with this other line? Because on the other part, I'm going to be locating 8.0. All right. So where is the 8.0? Let me get back. All right. So 8.0, you see, this is h right now, okay? Remember, I have located my own. I'm going to now be looking for 8.7. How do I get 8.7? Now let's get to this part as well. Now this is 8. And according to the same principle, 2cm is representing 1 unit. Therefore, one line is going to be 0.1. So this is 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7. So this is 8.7. Now the question should be, I'm going to keep tracing, sorry, cleaning that line. I'm going to keep tracing this line. I'm going to keep tracing this line until I see where it coincides with this file. So let me first clean all these ones. Now let's get back so that you understand what I'm saying. Good. So at this point now, see where we are. Okay. So I'm going to locate it. I'm sure you are seeing it very well. I'm not going to zoom again. Now I will trace this line. So see the line 8.7. That is 8.7. So where does this line come in? See the line. All right. So that is the line. 4.5 is this line. Correct. So the line I am trying to plot is this line. This is the line I'm trying to plot. This is the line I'm trying to plot, okay? Because if you trace it down here, if you trace it very well, you see this line, it continues going this way until 4.5. And if you also trace it down, I'm sure it's correct. Correct, 8.7. So that is the point. We are fine. We are fine with this one. All right, let's go to the next one. The next one is, please clean the other line. So the next point is going to be 3.8 and 7.8. Okay, so 3.8. So at this point, 3.8 on the vertical axis, see what this is 3 right now. 3.8 is going to be 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8. This is 3.8. All right. Now the next one is going to be, let me shift it so that good 7 is coming. 7 is in view, correct. So I'm having 3.8. Let me use this marker to indicate 3.8. This is 3.8, okay? Now, the next is 7.8, 7.1, 7.2, 7.3, 7.4, 7.5, 7.6, 7.7, 7.8 is this line. So where does it go? This keep going. Right. Now, where does the 3.8 goes? 3.8 comes from here. Sorry. Okay, so I was doing something. Yeah. Okay. So 3.8 came from here all the way. Correct. So I'm very sure is that point. So this is the point. So let's keep going. The next point we have here is, maybe you can copy the table down. The next point we have here is 3.3 and 7.02, 3.3. 3.3, 3.8 is there. So 3.3 is going to be 1, 2, 3. This is 3.3 and 0. 7.02. This is 7.0, 7.1. Okay, so 7.02, I will plot it as 7.1. That means it's not up to 1. What we have here is 0.02, but each line is giving me 0.1. Okay, now let's get back so that we'll be able to understand this. See, look at this. One line is giving me 1 divided by 2, which is, sorry, not one line. 10 lines is giving me 1 unit. That means one line is giving me 1/10, which is 0.1. Okay, but when you're having 7.02, it means you're having 7 plus 0.02. So what I'm going to do in order to be on the safe side is to assume a point called 0.2, 0.02. Okay, so if this is 7, 7.1 is here. So I'm going to plot it just a little above 7. If this is 7, okay, this is 7, this is still 7, right? Oh God, I didn't pick my marker. All right, so this is 7, 7 is here. So I would prefer to plot it at 7. So I'm plotting it here. I'm plotting it there, okay? The next one is 5.52. I'll be plotting at 5.5. 5.52 is here. Under 5.52, I have 2.6. So this is 2, 2.1, 2.3, 2.4. Sorry, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. This is 2.6. All right, I trace it down. So this is going to be 5.5. 1, 2, 3, 4, 5. 5.1, 5.2, 5.3, 5.4, 5.5. So this is 5.5. Okay, this is 5.5. And this is 2, 2.6. So they are meeting at this line. Okay. All right. I think we are finishing this. The next one is 1.5 and 4.2. 4.2 is 4.1, 4.2. So 4.2. This is 4.1, 4.2. This is 4.2. Okay, so where is 1.5? This is 1, 1.1, 1.2, 1.3, 1.4, 1.5. This is 1.5. You don't need to do this, right? I'm just using it to show you the traces. All right, so let me tidy up a little place because I'm going to draw the line, and the line I'm going to draw right now, I must have respect for line of best fit, okay? Now, I'm going to draw my line. If you look at this thing now, there are different ways the graph will go. Let me go back to default mode. Now, there are different ways. This is the graph I have plotted. Now, look at the issue. A student will come here now. A student will decide to draw his own line this way. Good. You see how a student drew this line? The question should be this line that this person, whether boy or girl, has drawn. Is it line? Oh God, sorry. Is it line of best fit? That is the question. I don't think this is not the line of best fit because, accurately, we are saying that this point, and this point enter the line. But 2 points fall out of the other side. To me, it's not the line of best fit because my line of best fit is such that if one point fall out here, another point should fall out here. If this point fall out here, then another point should fall out here. The points will be evenly distributed on the sides of the line. Therefore, I am going to also check another kind of line that another student may choose to draw. Wait, let me get. All right, so I am going to choose another line. No. Oh my God. So I'm trying to remove this line. No. I think I've entered into a bad. Good, correct. It's cleaned. Okay, so let's pick another line. Okay, I am going to draw it. Look at this line. This line will definitely be a line of best fit. Some people say, oh, at least 2, 3 lines will fall into the point. Okay, let me draw it this way. How many lines are falling? That's not correct. This is also not line of best fit because this point is out here, this point out here, this out. No. This cannot be a line of best fit. All right, so this is my line of best fit. Okay, why? When I look at this, I didn't have to, because since at least the 3 lines entered. When I look at it, I realized that 1, 2, 3 entered. I would have even included this last one because of the drawing, a little concern in the drawing. So all of them entered. 1, 2, 3, 4. They all entered my line, my point. Even though you may think that this did not enter, but if I have wind my hand because of this system thing, it would have entered. Okay, so this is my line of best fit. So if you look at it very well, I am basically saying that only this point is out. So this is my line of best fit. Now the next thing we are going to ask ourselves is, how do I find the slope? Let me complete this line. How do I find my slope? Okay, now in finding the slope, all you need to do is to pick 2 points that enter the line, whether it's one of the ones you plotted or not. Look at what I mean. I am going to do that by, let me consider this. Now look at the line, okay? If you look at this line very well, you realize that I can choose, okay, this one entered very well. Let me use another color. Let me use this part. Okay, so this point entered very well. Okay, which other point that entered in line very well? See, this point entered very well. This line can also be said to be to enter very well. Okay. So for that reason, I'm going to choose this line. Okay, and I'm going to choose this line. Okay, so this is where my my slope is. So I'm going to call this place maybe point A, point B, and point C. So this place I'm going to say is change in height, and this place is going to be change in E square. All right. So let's go back and calculate my slope. First of all, before I calculate my slope, I'm going to first, okay. So let me first clean this part and use it to have a better slope. And let's go back. Okay, so if you check very well, let's trace this. I'm tracing this down to this point. This is 3.3, okay? So 3.30 minus. So the next one is here. This is what? This line 0.11234 0.5. Okay, so 0.5 all over. Remember, this is slope. Okay, so let me just do it here. So I'm having slope is going to be 3.3 minus 0.5 all over. Let's find what this place is going to be and what this place is supposed to be. Okay. All right. So that should be 7 and 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. 7 and 2.6. So let's get back. 7 and 2.6. So this place is going to be 7 and minus 2.6. All right. So this is going to be 2.8 all over, and this is going to be 7 minus 2.6, which is 4.4. Therefore, the slope is going to be 2.8 divided by 4.4, which is 0.6. So I'm having 0.63. Now remember the slope. We are going to plot the slope, okay? Remember the slope. What are we plotting on the vertical? Vertical is, we are plotting cm on the vertical. So this is going to be cm over cm square. Now look at in mass. If you have cm raised power 1 divided by cm raised power minus raised power 2 is going to be cm 1 minus 2, which is cm minus 1. Therefore, the answer is going to be, slope is going to be 0.63 cm minus 1. All right. So that is our slope. Okay. This is our slope from the graph we just plotted. Okay. So, oh, shit. Okay, so this is how the graph was plotted. So this is how the graph was plotted, and I am sure you were able to understand everything that happened on this graph. But if you do not understand, you can always ask questions. Thank you so much. If you watched to this point, I would prefer you hit the subscribe button, like this video, and also share it in order to get to other people. Have a nice day.